Hello, everyone. This is Mrs. Lopez. We are in Module 4 for Grade 8, and this is Lesson 6. I'm actually combining Lesson 6 and Lesson 7 because I feel like they're very closely related and we can cover both of these topics in the same lesson. So, we have been learning how to um, translate the word problems into number problems. We learn how to solve equations with variables on both sides and check for a solution. Now, in this lesson, we are learning whether or not an equation can have more than one solution or maybe no solutions at all. Okay, so we are going to start as we usually do with solving equations. Here is example 1. What value of x would make the linear equation 4x plus 3, 3 times the sum of 4x plus 7 equals 4 times the sum of 7x plus 3 minus 3 true? So what we see here, we see a huge equation with variables on both sides that involves distributive property. So what we are going to do, we are going to open the parentheses using the distributive property and then combining like terms. We are going to do it to both sides of the equation. We will start with the left side. 4x plus 3x plus 7, I'm going to rewrite as 4x plus 12x plus 21, because when I apply distributive property, I need to multiply 3 by 4x, which will result in 12x, and 3 times 7, which will be 21. Okay? On the right side, I'm going to do the same thing, but distributive property only applies for 4 and 7x and over 3. That minus 3 is going to be our plus negative 3, and we will just leave it as is and just add it to simplified form. So 4 times 7x is 28x. 4 times 3 is 12, so plus 12. And then we will add negative 3 to it. Now we need to simplify what we have. So 4x plus 12x is 16x plus 21. On the right side, I'm combining 12 and negative 3, so it will be 28x plus 9. Now I want to think what I want to move and where. I like my x's be positive, so I'm going to get rid of 16x on the left side and move it to the right side. So I'm going to add negative 16x to both sides of my equation. Okay, I probably need to do it in a different color though, so I'll just underline it for now. Okay, so negative 16x and 16x make a 0, and I only have 21 left on the left side. On the right side, I am combining 28x and negative 16x, and I end up with 12x plus 9. My next step will be to get rid of the 9 that is on the same side as x. My goal is to have x on its own, right? So this is our two-step equation. I'm going to rewrite 21 equals 12x plus 9, and I'm going to add negative 9 to both parts. Okay, so now on the left side, I will have 12, and on the right side, I will have 12x, because 9 and negative 9 make a 0, right? Now I need to make 1x. That means I'm going to multiply 12x by the reciprocal of 12, which is 1/12. So I'm going to rewrite that, 12x, and I'm going to multiply both sides by 1/12. All right, so on the right side, I will have x left because 12 in the denominator and 12 in the numerator gets simplified to 1x. And on the right side, I will have 12 and 12 also get simplified. X equals 1. Okay, I can check my solution by substituting it instead of x into my original equation. So 4 plus 12 is going to be 16. And then plus 21, 16 plus 21 is 37. So we will leave it as 37 for now. Here I will have 28 plus 12, which is 40, and 40 plus negative 3 is 37 as well. So that makes my equation true. 1 equals x. All right. So that is a little bit more, involves a little bit more steps, but nothing that we cannot do, right? Let's look at example 2. Same exact system. We just need to make sure that we have all our negative signs turned into, all minus sign turned into a negative. So we'll have plus negative here, plus negative here, plus negative. Here we already have negative. Okay, now notice there is no distributive property. However, we do have the opposite of the sum. So I am going to put 1 in front of parentheses just in case, so you can see that it is a distributive property and I can distribute negative 1 over both parts inside the parentheses, both numbers inside the parentheses. So when I'm going to open the parentheses, either applying distributive property or knowing that the opposite of the sum is the sum of the opposites, I will get 20 plus negative 3x plus positive 9, and then I will have plus negative 2 because distributive property does not apply to the numbers outside of the parentheses. And then I will have equals 11x plus negative 1. Okay, now I'm going to combine like terms. I will combine 20 and 9 and negative 2. So 29 plus negative 2 is 27. So I will have negative 3x plus 27 equals 11x plus negative 1. Again, I want my x's to be positive. It's my personal preference. You can do negative x and then multiply by the reciprocal of a negative number. Nothing wrong with that. So I will get, what I want to do is I want to get rid of that negative 3x by placing it to the right side. So I'm going to rewrite this first. Negative 3x plus 27 equals 11x plus negative 1. And I'm going to add positive 3x to both sides of my equation. Okay, on the left side, I will have 27 left because 3x and negative 3x cancel each other out. On the right side, I will have 11x plus 3x, which is 14x, plus negative 1. Now I'm moving that negative 1 into the left side because I want to have x on its own. So 27 equals 14x plus negative 1, and I'm going to add 1 to both parts of my both sides of my equation. So I will have 28 equals 14x. Okay, so now what I need to do is to find the x by multiplying both sides of my equation by the reciprocal of 14. 28 equals 14x, and I'm multiplying by 1/14 both sides. 2 equals x. Let's check, make sure that our solution makes sense. So we will put 2 instead of x into our original equation. So I'm going to write here to make sure that I got all the signs and numbers correctly. So I will have 20 plus negative 1, and I'm going to multiply that by 3 times 2 minus or plus negative 9 plus negative 2, and that would equal to opposite of negative 11 times 2 plus 1. Okay, so here I will have negative 1 times So here I will have 6. 6 plus negative 9 is negative 3. Negative 3 times negative 1 is positive 3. So I will have 20 plus 3 plus negative 2. On the right side, I will have negative 22 plus 1, negative 21, positive 21. All right. So here I will have 23 plus negative 2 is 21 equals 21. Since 21 equals 21, my solution of 2 equals x is correct. Okay, let's move on. Example 3. Exactly same process here. So opening parentheses, first we are changing subtraction into addition of the opposite. Make sure you do have that step done because it does get confusing when you don't. All right, so opening the parentheses. 9 times 4 is 36 plus negative 18x plus negative 3 equals 4 plus negative 18x plus 30. Okay. So now I need to make sure to add like terms. I can add 36 and negative 3 on the left side. So it will be 33 plus negative 18x. And on the right side, I will have 4 and 30. So 34 plus negative 18x. Now I need to, I like to have positive x, as I always say. So I can move either one to the other side. So I'm going to rewrite this. 33 plus negative 18x equals 34 plus negative 18x. And I'm going to add positive 18x to both sides. All right. So on this side, on the left side, 18x and negative 18x get simplified, and I will have a 0. So all I have left is 33. On the right side, also negative 18x and 18x will make a 0. So all I have left is 34. So now what I see here is 33 equals 34, which is not true. We know that 33 does not equal 34. That means this equation does not have a solution. No solution. We discovered something new. Apparently, an equation does not have to have a solution, right? Before we were finding a solution. Now there is no way we can say that there is a solution, because no matter what x is, if I substitute it instead of x, if whatever number that is, I will end up with a 0 on the x side. All right, so there is no solution. Okay, let's look at example 4. 2x plus 1 equals 2x minus 3. So I'm going to open the parentheses. 2x plus 2 equals 2x minus 3, or plus negative 3. Notice again, and I don't even have to do all of this work that I did in example 3. So here I was moving my 18x to both sides to see that I can actually make a 0. If we look at example 4, we see that there is 2x on both sides. And it doesn't matter which one I'm going to move. It's going to move with the opposite sign. So it will be minus 2x on both sides, minus 2x on this side. We will have 0 on both sides, no matter which one we are going to move. And what I will have left is 2 equals negative 3, which is not true. So I can say right now, right away, without even doing all this work, that this equation does not have a solution. No solution. And again, I know it because I have exactly same variable and different constants. Same terms with a variable and different constants. Okay, I can say same coefficients, different constants. Every time you see this, you know it's not going to have a solution. Okay, let's look at example 5. 7x minus 3 equals negative 3 plus 7x. Okay, so I will change my subtraction into addition of the opposite. I will get 7x plus negative 3 equals negative 3 plus 7x. I can move my x's to either side of my equation. We can see that 7x is 7x already, right? We can see that right away. 7x is 7x. We can also see that negative 3 is negative 3 on the right side. So we see that both parts of my equation, both sides of my equation, are exactly the same. If they are exactly the same, it does not matter what number my x is. It means that all of them are going to have a solution. So if my x is 1, I will have 4 on this side and 4 on this side. If my x is 2, I will have 14 minus 3, 11, and 11 on this side as well, right? It doesn't matter what x is, I will always have a solution. In this case, when we have the same variable, the same constant, the same coefficient, we will have infinite solutions to this equation. Infinite solutions. Coefficients and constants are the same. All right. We have, I believe, a last example before we switch to the exercises. Yes. So here we have 2 in parentheses 3x plus 5 minus 4x. On the right side, 10 plus 2x. Let's see what happens when we simplify. 2 times 3x is 6x plus 10 minus 4x, or plus negative 4x, equals 10 plus 2x. I can combine like terms on the right, on the left side. 6x plus negative 4x is 2x plus 10 equals 10 plus 2x. Right away, we see that we have the same term with the same coefficient of 2, and we have the same constant. Means I have infinite solutions. I don't even have to continue solving this equation. All right. So now it's your turn to try the exercises. And when you're done, pause the video, solve them. And when you're done, we will go over the answers together. All right, so we are back together and checking for solutions. For number 1, after you simplified this equation, you will get 17 plus negative x plus 45 equals 6x plus negative 10 plus 4. After you simplified that and combined like terms, you will see that you will have 62 plus negative 10x equals 6x plus negative 6. Since you see that there is negative 10x on the left side and 6x on the right side, you can say that this equation will have a unique solution. And sometimes the problems will not have you solve them. Here they're asking us to find the value of x, so we need to continue solving them, okay? After you simplified, I moved my negative 10x to the other side, so I added 10x to both sides. And after all that simplifying, and I'm sure you know how to do this by now, my x is 17/4. Okay. Number two, I simplified by opening the parentheses by using distributive property. And after I did that, I ended up with 13x plus 20 equals 13x plus negative 33. Because I have the same coefficients of x and different constants, I know that my equation is not going to have a solution. No matter what number I will put instead of x, I will end up with 0 for the x. Okay. All right. So moving on to the next one, number 3. Number 3, so again, we open the parentheses by either using distributive property or like for example here I have the opposite of the sum, so I just need to change the signs of both numbers inside of parentheses. After I simplified everything, I got 4x plus negative 13 equals negative 3x plus 15. My coefficients of x are different, so I know my equation will have a unique solution. Again, sometimes you will not need to find that solution, but in this case we do. So after combining like terms and moving my x's and my constants to different sides to isolate my variable, solving the two-step equation, I'm going to get x equals 4. For number 4, I combined like terms and I saw right away that I will have 9x plus 15 on both sides of my equation. So it means that my equation has infinitely many solutions. I don't need to continue solving it. Um, I know my answer to this equation. Okay. For number 5, after opening the parentheses using distributive property and combining like terms, I got 3x plus negative 41 equals negative 4x plus 5. I know right away because my coefficients are different, I know I will have a unique solution. So that's why I continued solving it. And once I did, I ended up with x equals 46 sevenths. For number 6, after I opened the parentheses using distributive property and combining like terms, I ended up with the same coefficient of x and different constants. That means I will have no solutions. For number 7, um, again, after using distributive property and combining like terms, I ended up with 4x plus 13 on both sides. It means everything is exactly the same, so I will have infinitely many solutions. For numbers 8, 9, and 10, you needed to come up with your own equations that have either no solution or unique solution or infinitely many solutions. So for number 8, I ended up with just writing a random equation knowing that my coefficients have to be different, the same, and constants have to be different. So I wrote 3x plus 5 equals 3x minus 3. I know that coefficients are the same. That means if I decide to move them to the same side of my equation, I will end up with a 0, and I will have 5 equals negative 3, which is not true. I also did negative 2a minus 7 equals negative 10 minus 2a. Minus 2a is negative 2a on both sides of my equation, and I also have different coefficients. It means I will have no solution. For the unique solution, everything can be different. Well, even the constants, they don't have to be different. They can be the same, but the coefficients of x have to be different to find a unique solution. So I ended up with 3x plus 5 equals 4x plus 7. And for my second one, I have negative 2a minus 7 equals negative 10 minus 3a. Okay. For the infinitely many solutions, I wrote one which is more complicated one, and the other one is very simple. So I will start with a simple one. Everything is the same. Negative 5 plus 10x equals negative 5 plus 10x. That means I will have infinitely many solutions. For the first one, I wrote negative 2 times the sum of 3x plus 5, which is negative 6x plus negative 10, which is exactly the same what I have on the right side. That means I will have infinitely many solutions. Okay, so this is our lesson 6, which is also lesson 7, and that concludes our topic A for this year in module 4. So go ahead, do your problem set, and we will continue talking about it in class.